Yes, guys. So now we will see and we will write some kind of a script to automate this compilation process. So let me create what I can say baby step 2. So in baby step 1, so what exactly we have done? So we understood about like how this compilation works. And in the next stage, so basically in the baby step 2, we will write some shell script and we will automate this one. So what exactly I'll do is, so I'll say run.sh. So just I want to run this. So then what I'll do is, I'll copy this one and I'll paste it here. So this is main.c, so which is in the baby step 2. So then what exactly I'll do is, so what we were doing, so we were doing something called a GCC main.c. That's it, right? So then I'll go to my terminal. So then go back to baby step 2. So then ls. So let me give an executable permission for this run.shell, this shell script. So simply execute run.sh and type ls. Can you see a.out is getting generated and we can execute this a.out. And also in this baby step 1, I forgot to explain about like how the C++ compilation works. So there is no much difference between C++ compilation. So what exactly we have to do is, so let me create a new C++ program. So I'll say main.cpp. That's it, right? So I'll say instead of stdio, so I'll say IO streams int main and stdcout hello world. Yeah. So basically what exactly I'm doing is, so simply I'm printing a hello world here. The only difference between the C and C++ compilation is, so just we have to use a G++ compiler. So which is nothing but a C++ compiler. And then same -temps if you give, so it will generate an intermediate file. Then I can say main.cpp, enter. So once you enter that one, here you can go and see. So basically the only difference between C and C++ is the intermediate extensions which is getting generated, which is nothing but .ii. So that is the one difference. So basically if you go to the end, so here you can see the number of source code which is being copy pasted from the header is too much. So earlier it was around 800 number of lines, right? Now you can see there are almost like 36 lines of code is being automatically getting pasted here. Then rest everything remains the same. The assembly code for this particular thing is been generated and it is little bit changed compared to C program. So the code which is generated from the C program, which is much more linear compared to C++. So ultimately at the end of the day, what exactly this C++ or C is doing? So it is basically an automation tool, so which is generating an assembly code, correct, right? Then this assembler is taking this assembly code and generating a a.out, which is nothing but a binary. And this is exactly, it is creating my object file, and this object file is been linked with another libraries, which is nothing but a libc and some other library. In case of a C++, if I go here and check, basically a.out, can you see here? Apart from normal libc, it is also linked with std C++ as well. And along with that one, it is having libc, and rest everything remains the same as if it is a C program output. So a.out, so it is all working fine. So this is on a high level of like how exactly this C++ compilation works. So now we wrote a script for this one. Now, so what exactly do? So we can even change this one to CPP. So just we created some automation tool, that's it, right? So if I do run.sh, here can you see? So a.out is getting generated. And if I want to change the output name to, let's say, hello_word, this can also do my job, right? So basically I'll do run.sh and I'll say ls. Can you see? Hello world is getting printed. This is on a first level of automating your compilation things. So, but this does not scale up. So basically the meaning of scale up is, so it cannot be useful for like bigger kind of projects. So that means it cannot be used for a bigger projects. So this is only for experimental, like small chota mota experiment if you want to do. So you can write an automation tool in the shell script. Now the other automation tool, or like which exactly used in real-time industry, which is nothing but a Makefile. So now we will see how can we write a Makefile. So for that one, what I'll do is I'll delete all this thing. And here, so let me minimize this one, close this, close this, close this. So here, let me create a Makefile. And here you should observe, so all the things, so whatever I am typing here, so it is case sensitive. So that means name should be capital and rest everything should be in a small letters. Now, in order to understand this Makefile, you need to understand whatever the compilation steps we have done, how can we do it step by step? So that means instead of giving save-temps, you should know how you can generate this step by step manually. What exactly I meant is, so now we have a main.c. So let's take a GCC compiler. So now if I pass -E and I'll say main.c, if I enter, can you see all the intermediate file is printing on my console. So instead of that one, I need to redirect to something called i, main.i. So intermediate file is generated. So if I go here, open this one, so the intermediate file, whatever which was generating earlier using save-temps, now I am generating manually using -E, so which is directly printing on the console. But now I redirected this one to main.i. Now for the next step, what exactly we need? So we need main.i, right? So either you can use main.c or main.i itself is enough. So what is the next step? We need to generate what? So we need to generate an assembly code, right? So give -s, then go here and here where, so I think it's not a small s, I feel it's a capital S. So yes, so when I do this capital S, can you see main.s, the assembly code is been getting generated. So I'll repeat again. So what I'll do is I'll remove this assembly, I'll remove this intermediate file. So what exactly I did is, so I generated an intermediate file by giving main.c and redirect this one to main.i, because all the output will be coming on a console. Enter. So now I generated main.i. So now I need to generate an assembly code from this main.i. The command is gcc-S main.i. So this time you no need to redirect. By default, it is generating a file. It is not redirecting to, or it is not printing on a console. Enter. So now if I do ls, can you see main.s been generated? So I'll go here. Can you see main.s is getting generated? Now take this one and convert into object file. So how can I do that one? So use gcc-c and I'll say main.s. Enter. So when you do ls, can you see main.object is getting generated? So here where main.object, when I open this one in a text editor, it is a executable and linkable format. Now I have this main.o. Now I need to link this one to some other libc and all other stuff. So in order to do that one, simply what you can do is give this main.o. So rest everything will be taken care from the GCC. You no need to explicitly search for this libc and all the stuff. You no need to do all the things. So simply enter and you say ls, you got a a.out. So you may think like a.out was earlier there. So let me remove this one, type ls. So can you see here, there is no a.out. So let me compile this one again, clear the screen, gcc, you give main.object file, enter. So then you will get a a.out. So if you want to change the name of the executable, what you can do is gcc main.o, then you can see what is my output name. So let's say hello is my output name, enter. Once I say ls, can you see? Now the output is getting generated with hello. So I can execute hello. So this is how you can do the things. So basically all this Makefile, instead of before writing into the Makefile, all this compilation steps is being divided into further steps, and each step so we can control using -e for intermediate file and -S for generating an assembly code, -c for generating an object file, and basically without any arguments, so simply you give this object file to the compiler, so it will generate an a.out. So this is the manual steps for generating each of the compilation steps. Now maybe in the next video, since it is becoming very much bigger, the lengthier video, so in the next baby step, so we will see how to write your own Makefile.